Selective repeat and its potential problems. So selective repeat is an alternative strategy to the go back in protocol if the line is poor and bandwidth is wasted on retransmitted frames. This allows the receiver to accept and buffer the frames following a damaged or lost one. So the way this works is a frame arrives, its sequence number is checked by the function between to see if it falls within the window. If it does, and it has not already been received, it is accepted and stored. Now there are some potential problems with selective repeat. This action is taken without regard to whether or not the frame contains the next packet expected by the network layer. It must be kept within the data link layer and won't be passed to the network layer until all the lower numbered frames have already been delivered to the network layer in the correct order. And another potential problem is non-sequential receive introduces further constraints on frame sequence numbers compared to protocols in which frames are only accepted in order. So here's a problem explained in a disaster scenario. So suppose lightning strikes a telephone pole and it wipes out all the acknowledgements. The network layer gets an incorrect packet and the protocol fails. Now, why did this happen? After a receiver advances its window, the new range of valid sequence numbers overlapped the old one. So the following batch of frames might be either duplicates or new ones depending on whether the acknowledgements were lost or received. Now the problem with this is the receiver has no way of distinguishing between whether or not they were lost or they were received. So there's a way to prevent this problem. In order to avoid this problem, you must ensure that after the receiver has advanced its window, there is no overlap with the original window. So in order to ensure that there is no overlap, the maximum window size must be at most half the range of the sequence of numbers. So in general, the window size for protocol 6 will be the max sequence plus 1 divided by 2. So here's an example of the correct process working. And so as you can see in figure A, initial solution with window size of 7. So this is the window size of 7. In figure B, after 7 frames have been sent and received but not acknowledged. In figure C, initial situation with a window size of 4. So here you can see the 4. And then in figure D, after 4 frames have been sent and received but they're not acknowledged. So how many buffers and timers must the receiver have? Under no conditions will the buffer ever accept frames whose sequence numbers are below the lower edge of the window or above the upper edge of the window. The number of buffers needed is not equal to the range of sequence numbers, it is equal to the window size. The number of timers needed is equal to the number of buffers. The number of timers needed is not equal to the size of the sequence space. A timer is associated with each buffer, and when this timer runs out, the contents of the buffer are retransmitted. So Protocol 6 error handling. So the Protocol 6 relaxes the implicit assumption that the channel is heavily loaded. If the reverse traffic is light, the acknowledgements may be held up for a long period of time, which can cause problems. If there's a lot of traffic in one direction and no traffic in the other direction, the protocol will block the sender window when the sender window reaches its maximum. To avoid this, an auxiliary timer is started by start act timer after an in-sequence data frame arrives. If no reverse traffic presents itself before the timer expires, a separate acknowledgement frame is sent. An interrupt due to the auxiliary timer is called an act timeout event, and only one auxiliary timer exists, and if start act timer is called while the timer is running, it has no effect. Now some more error handling. When the receiver suspects an error has occurred, it sends a negative acknowledgement or a NAC frame back to the sender. The variable no NAC is true in Protocol 6 if no NAC has been sent yet for the frame expected. It does this to contain whether or not a NAC has been sent yet. It's Boolean. If the NAC is mangled or lost, the sender will eventually time out and retransmit the missing frame anyways. If the wrong frame arrives after a NAC has been sent or lost, no NAC will be true and the auxiliary timer will start. When the timer expires, an ACK will be sent to resynchronize the sender to the receiver.